All right. Let's see. I'm just gonna start doing this, and maybe they join when we actually get to the discussion topics. So okay. Let's see. This week, closed PRs. There was a Prometheus PR that just lets you disable the cache. I think that's pretty simple. So that merged. Um, Igor had a PR for capping the OMAP naming scheme. Holy smokes. I don't remember what this was. I think this, I don't remember. I'm sure it was basically to eliminate some kind of corner case, though. Yeah, we shouldn't use single per ONode transaction for such an upgrade when ONode's OMAP list is huge. Yeah, high memory consumption. Okay, so it's basically just making it so that we don't end up consuming tons of memory when there are like huge OMAP lists in a particular ONode. Single per ONode transaction. Okay, so it splits it up. Okay, yeah. So basically, just not letting you blow up the OSD when things are awful. Um, all right. In the MDS, there was a PR that merged that switches the MDS lock to a fair mutex to avoid starvation issues. So okay, that looks good. Bunch of updated PRs. This one from Adam, we'll talk about that I think a little bit later. Adam's not going to be able to make the meeting, but the gist of it is that this PR does direct I/O for writes and then buffered I/O for reads. And so the concern there, the benefit there first is that it's kind of giving us the best of both worlds in terms of what we've seen for performance potentially. But the concern is that this could introduce consistency issues if you're trying to do things like read from cache while simultaneously you have direct I/O writes going on. So that would need to be very carefully audited, I think. Okay, what else? This incremental update mode for BlueFS log that failed QA. OSD compression bypass after RGW compression. Looks like that made it into Eric's testing branch, so maybe that's possibly going to merge if it passes. More ongoing work with this TTL cache implementation for the manager module. I think that had another review. Igor's optimized PG removal PR that had failed tests at one point, and I think it just got another review. I don't remember who looked at it recently, but that was reviewed again, so more ongoing work there. The Ceph messenger header 2 decoding optimization that's gotten updates. Ilya previously had reviewed it. I think there were test failures at one point. I'm not sure if that's still the case or not. And then the other big one for me, the one I've been excited about for a long time, is this MDS remove subtree map from the journal. I wasn't sure if that would just languish, but it looks like Zheng has updated it again. So, or at least, yeah, he did. I'm not sure exactly what he did there. Maybe just rebased it so that it's current, but he's been actively, periodically keeping that up to date. So hopefully we'll be able to get that in. That looks like a really good PR if it works. And then that was it for updated PRs that I have. Is there anything I missed or anything anyone wants to discuss related to those PRs? All right. moving on then. So I've presented some of this data to the core team already, but I'll share it here as well. Last week and earlier this week, I did some work looking at the OSD code in master. I had noticed that it looked like we had regressed somewhat versus when we started Quincy. So I wanted to go back and dig around and look for it. And in the spreadsheet that I just posted in the chat window, you can see the results of that work. There's good news and bad news here. The good news is that it wasn't anything super unexpected. We had been worried that there were some mclock changes for QoS that we're a little concerned may have introduced regression. But it doesn't really seem so. Maybe a little bit. There was some fluctuation that I didn't really dig too much deeply into, but it's not clear that it was anything other than just random variation. The real big source of regression, well, there are two that we saw. One we already knew about and fixed. That was A7E3 ECE on line 16. That was a change that was introduced that Mark Hogan actually discovered first, where we ended up basically doing debug builds by default, and that was a real nasty impact. But that got fixed, so that was no longer a problem. The other change that we kind of suspected and also kind of already knew would potentially cause some regression in this kind of workload was when we switched to using BlueFS buffered IO true by default again. We've gone back and forth on this a couple of times. The reason that we switched that back to being true again is that for some reason that we still don't totally understand, RocksDB will not read blocks that you've read during iteration, like iteration over collection, recently from cache. For some reason, it seems to go back to disk again when we have this kind of pattern. It may be that we did something like deleted something that caused invalidation of the cache. I've seen that in RocksDB before, where potentially like you do a compaction and the entire cache is invalidated. It's kind of weird. This maybe something like that is going on, or maybe just their behavior is kind of broken. But what we've seen is that RocksDB will often, maybe always, go back to disk when you reiterate over something that you just iterated over, rather than using the block cache. So what happens is that the buffer cache ends up doing all of the heavy lifting. It will, if you do direct I/O, you'll end up just doing all of your reads from disk. But if you have a significant amount of buffer cache, then you'll end up doing those reads from memory instead. So that's why we made the change, because people were noticing this for real deployments during any kind of operation that would require collection listing or deletion or other things, and it was bad. We also were sort of able to replicate this ourselves through a benchmark I wrote called OMAP bench. That's just part of, well, it's not yet. There's a PR for it, but we've merged it. Part of the make test or the gtest suite. And you can see some of those results here on lines O and P, where with buffered IO we're quite fast across the board, and in column P, when we have direct IO on, you can see that OMAP get and OMAP remove, the time it took to do those tests increased fairly dramatically. So all this is to say that right now we're in kind of a hard place, where on one hand, direct IO for us is faster for things like RBD 4K random reads, but it potentially is significantly slower for OMAP operations through RocksDB for things like collection listing. Um, the good news here is that while if you go back to the other spreadsheet in the looking at the bisection results, Gabby had earlier during this release or during this development cycle implemented a PR that removes all of the allocation data for BlueStore out of RocksDB, and that was a significant performance win for things like 4K random writes. In that case, I think his PR is probably worth about a 20 or 25% improvement, and it basically makes it so that even with when using buffered I/O, we're actually faster than we were when we started Quincy. In those results, you can see that, in fact, by switching back to direct I/O or RBD 4K random writes, it's even faster. We're gaining like another 10 or 12%, but we don't strictly need it. We're still faster overall than when we were when we started Quincy. So there is one other thing in here. I had mentioned Adam's PR about doing direct I/O writes in BlueFS and buffered reads. That got us back to the 4K random write performance we're seeing in direct I/O mode. It's possible and even fairly likely that we'll see the kind of better performance in the OMAP read and deletion tests with that PR. Maybe it's the best of both worlds. The downside with this, as there's some discussion in the PR you can see, but the real downside with this is that it can be very difficult potentially to guarantee consistency when you're doing reads from the Linux page cache while simultaneously doing direct I/O writes. We will need to be extremely careful, I think, if we go down that path to make sure that we're not introducing any kind of inconsistency in corner cases. But just for the sake of argument, it looks like there's potential there. So it may be worth further investigation. I see everyone from Core joined. So yeah, I'll open it up. Does Gabby, I wanted to specifically mention how great your PR is looking. Any concerns or comments? I'm not hearing you, but maybe my audio is broken.
No. Gabby is not heard.
Okay.
Okay, can you hear me now?
Yes.
Yeah, sorry, my mic is keep jumping between different definitions. So I saw in the doc in the tables that the commit levels seems very far away. Did you just compare the code from before my commit and after, or there was a big difference in between with many other commits coming in between?
Gabby, I believe that on line 17, E21V68D, I think is the commit right before yours. Is that okay. Incorrect?
No, I just maybe I remember this incorrectly. But okay, so it was just between these commits, and we jumped from 10,625 to 1,395, which seems about 25%. I didn't do the math. I'm just doing this by head.
Yeah. And honestly, it's all messy, right? Because that was during a severe regression that was introduced because we ended up doing debug builds by default.
Okay, so it seems we got the same improvement we expected. And again, it stands to reason because we skip a major step in the I/O flow. So it's expected that you will gain some significant improvement.
Yeah, I would look at line 27, that result, and compare that to probably line 15. It's not exactly apples to apples, but sorry, no, line 9. Actually, that would probably be the more. Sorry.
So line 9. Which lines?
9. and compare that to line 27 approximately. That
Nine
is not exact, but
27.
it's you
Well,
know
there is huge jump, but there seems to be much more than that. What are the differences? Is
there
it
is there's a
just
lot of
because
difference. The problem that we have right now is that we don't have any direct comparison, right? We basically before line 10 when we enabled BlueFS buffered IO by default, we were seeing fairly consistently around 66 to 68,000 IOPS for this particular 4K random write test. Once we did that, we were dropping down to like 58 to 61, I guess. Um, and then when we introduced the regression that made us compile by default, debug by default, of course, then it was significantly worse. So I guess really the significant changes over master that we saw were, if you exclude this debug issue, was when we disabled BlueFS buffered IO and when we introduced your PR. So those are kind of the really important parameters to look at. Line 27 is the average of those three runs in master head as of like a week ago, roughly.
so number 27 is combined of disable buffer IO and no allocation and disable column family B?
That's just whatever the state of master is with your PR. So assuming that your PR does that, then yes.
Yeah, so no column family B plus disable buffered IO.
Exactly,
And
exactly.
the baseline is what we see in row number 9. So that is okay. I need to open a calculator. Really, I mean, really, I'm too slow to do anything by head anymore.
I understand. I feel you.
I used to be able. Okay, now I have the calculator, and so we do 81,900
Yeah,
divided
approximately.
by 68,100. That's 20% improvement. Actually,
Yeah.
it's but I thought we saw better improvement when we looking at 17 and 18. There was a bigger improvement. Let me double check it. So maybe the combination is not that great. Or is it the same
Well,
test? It's doing small IO?
yeah, exact same test, exact same configuration.
Okay.
There will be some random variation involved, but the bigger thing here, right, is that I mean, on
So,
those lines, it's debug build. So I mean, you can't
but
directly
no,
compare, right?
when I check the difference between line 17 and 18, it's exactly 25%. When I
Sure.
check 9 and 27, it's 20%.
But Gabby, it's a debug build, right? So I mean, we can't really directly
So
compare these things.
27 is in debug and 9 is without debug?
Essentially, yes. That was what the regression that was introduced, which is why those numbers are so much lower in 17 and 18. It
Okay.
overlapped with your
So,
PR.
okay. So we can't really, no, but number 27, there is no debug, right? I mean, there's no way you could
Correct.
get these numbers with debug.
Exactly, exactly. But that was the problem with 17 and 18, is that when
Oh,
your PR was
17
actually
and 18 are working in debug mode, and 27 is without the debug mode. Could we
exactly.
get 17 and 18 in non-debug mode to see what kind of
It,
difference we get? Maybe, because maybe there's a lot of debug messages in the code I removed.
I mean, we could manually apply the fix to those, but I mean, Gabby, I don't think it's really worth it. I don't think there's anything that merged after that that was really impacting performance that I could see.
But there is the difference between 9 and 27. There's also the difference of buffer IO being disabled,
Yes,
right?
yes, yes. But look in master. We've got the on line 31. You can see the case when we have bluefus buffered IO true.
Okay, so buffer IO true gets you down to 73. So buffer IO true is the same. So line number 9 is also buffer IO true, right?
Correct. That was from before your
So it
PR.
seems that my improvement from 9 to 31 is not very much.
Oh, sorry. 10 is buffered IO true. 9 is buffered IO false. Sorry, I misstated that.
Okay, okay. Okay. So in buffer IO true is 57. Let me do the math. So 73,316 divided by 57, 627. So now we get 27% improvement. Okay, so when buffer IO was disabled, there was 27% improvement.
And when it's on, then it was more like a 20%. Or sorry, when it's, yeah,
Yes.
when buffered, yeah, when you're
Okay.
doing direct.
Okay, so 27% is the raw improvement, but by making buffer IO disabled, we able to gain more, and the improvement was more significant without my changes because it made them much faster than they used to be.
I think my takeaway from this is that when you're using buffered IO, your improvements are having a bigger effect, and when you're using direct IO, there's not as big of an effect, but that just might mean that there's a bottleneck somewhere else that's impacting us more.
Yeah, so by disabling buffer IO, you remove a bottleneck, which was part of the work needed for column family B. So that was making them slower. Without buffer IO, the IO was just slower, and column family B work was affected by this. When you remove this bottleneck, then you get improvement for column family B work, but removing that code makes even better of improvement. Okay, so I take it 20% with buffered IO and 27% without it. The other way
I think it
around.
was the other way around, right? I think it was
Yeah, the other way
27%.
around. Yeah, I mean with buffer IO disabled. I'm saying disabled. Yeah.
Yeah,
With it
yeah.
being disabled, which is another way of saying without it. Okay. And the test is 4K random write, right?
Yes, yes, with a relatively high IO depth, the data set size tuned so that all O nodes fit inside the O node cache.
And 24 to 27, what's the difference between them?
Let's see, 24, 27. 27 is just the average of those three separate runs.
Okay. It's the same test, just you got an average number. Okay.
Yes,
And
yeah.
829, 30 is the same run, and 31 is the average.
Yeah.
And I would assume that 11, 12, 13, no, sorry. If you look before, do you also have numbers and then average?
No, those were just individual steps
It's
through.
different code level, sorry, different code level.
Yeah, exactly. Because I didn't want to do 3 runs for every single commit on the
Okay.
the bisection unless I needed to. It was really clear this time, so I didn't really need to gather more samples.
Okay. So all in all, we are in line with expectation, which is good.
Yes, exactly. Yeah, your PR is looking great. And like I said, it's the only reason right now in Master Head that we're faster than at the Quincy launch. So kudos. That's a really good result.
Thanks. I
One
mean,
thing
we still need to root out some issues that we've seen impacting correctness. I
yes.
hope. Yeah, I hope. So one of them we fixed, and I hope it will get merged soon. It's finished. Um, there are two which we're still investigating. One of them, Adam thinks, might be unrelated to my changes and maybe is in his domain. The other one, I have no explanation, but I was able to see that with my changes disabled, we are unable to get these failures. And with my changes enabled, the failure happens on tautology boxes. I'm still unable to get this thing to fail on my box. Maybe I'm doing something different in tautology, but maybe my environment is different, but this thing doesn't fail on my box, which is very annoying. Again, none of them seems to be, it's not going to change the way we do things. There's probably some uninitialized something somewhere. So I don't expect that we will need to do major changes once we find the root cause.
Cool. That's good. Good. And yeah, I wouldn't doubt that there's a possibility that your PR just exposed some pre-existing issue. There's certainly enough complexity here that that
So
very
one
easily
of
because
them, it might be, and the other one, I don't know. I'm still thinking maybe I'm doing something too fancy for BlueFS, the way my file is stored. I'm doing too many truncate and such, which other stones seems to be using. Maybe BlueFS doesn't like truncation.
well,
But
if it's
we can
true though,
explore that
that's
area.
it's, yeah. If it's true though, we need to fix it because there's no guarantee that something else couldn't come in and do the same thing.
I think I'm the only one doing truncations.
Okay. Hmm. Well, in any event,
Yeah, but
get
like
it
you said,
fixed.
we
Go ahead, Gabby.
okay.
Um, so the only other question here that I was kind of thinking about is, as Adam was talking about, his PR for doing direct writes and buffered reads, is if this may be another, maybe this is the time to start looking at IOU ring again and potentially running IOU ring in buffered mode, seeing how that does. We have some code for IOU ring, but I don't know if it's even working at this point. That whole interface has gone through some churn in the last year, so it's maybe worth reinvestigating it. Gabby, have you ever looked at IOU ring, or
Mark,
anyone else
did
for
you
that
got?
matter?
Sorry,
Yeah,
Mark, did you
I was wondering if.
I wrote a Ewing application, but the past not in Reddit, but we made use in Indigo Fire Ewing, but not sure I remember a lot of what I did there.
We so Ronan, we have code that came in from an external contributor that kind of hijacks our AIO path to support IOU ring, and I mean, even at the time, it felt a little hacky to me, but it more or less worked. But I wonder if it might be time to start thinking about IOU ring as a first class, kind of citizen for BlueFS.
Can you send me if you remember what to look for? Where is the PR that?
Yeah, and I think actually it's all self-contained in the Blue Store directory. Let me look. Well, that's not self-contained. That's not entirely true. But the source store somewhere in here. Now I thought that it was actually in a separate file, but it might not be. Yeah, let me look it up, Ronan. I can send it to you. I actually don't remember exactly what the state of it is, so maybe I'm misremembering something. But I thought that we supported it in BlueFS.
I seem to remember from our last discussion a year or so ago that it was supported, but I don't remember the details.
Oh, we moved kernel device out of here. That's right. Being common now. Just doing a find. Source block kernel. Okay. Sorry, I couldn't remember where we moved that to. So here we go. Here's IOU ring. Okay. So the IOU ring code itself is here. Now, I have to admit, I don't even know how much this has changed. I know it got moved, but I don't know how much has been changed since then.
27 days ago, or just moving it?
Yeah, it doesn't look like there's been a ton of changes.
The code here seems general, not specific. I'll take a look.
Yeah, like I said, I thought that we were somehow hijacking our AIO code for a lot of this. But anyway, yeah, take a look. Tell me what you think. You probably are one of the few people that's actually done anything with IOU rings, so I'd definitely be curious to see what your thoughts are.
Okay, the code here was just upgraded from written 3 years ago and upgraded for new minor library changes during that time.
Yeah, I doubt anyone's even really tested it much. I once tested it a long time ago, and that was it. That was even before CentOS by default supported it, so you'd had to use custom kernel. Now maybe it's different.
I think it's part of some of Crimson tests. We tested Sistar with over IOUing.
Oh,
But
that's excellent.
I don't remember what was the status and what were the results. I've probably Radek or Kifo is the one I think who was doing it, but I'll ask Radek about it.
Okay, cool. All right. I think that's all I've got. So I'll open it up. Any other topics that people want to talk about today? Gabby, I think your dog maybe wants to talk about something.
It's my neighbors. I don't have it.
Okay.
Yeah, that's the living in the city. We are not like you guys living in your own kingdom of isolation.
Yeah. I remember the apartment days. That's it's mixed, right? Good things and bad things.
Yeah, but noises are just all over the place. But it's fun.
Indeed. All right. Well, if
So
no one has
who is
anything,
working
oh,
on the? Do we have a project using the U-ring?
we we sort of did at one point, and code was implemented, and it more or less worked. I don't know, a year or two ago. But it wasn't showing any particular improvement. There was very little difference compared to using the AIO interface. Theoretically, it may have shown some benefit in that we were actually at the time able to make IO submit in the AIO path stall, which it's not supposed. Well, it's theoretically maybe sort of not supposed to do, but in reality, you can make IO submit stall in the AIO path if you have too much backed up IO. Um, so I think IO Uring might help in that case, but in reality, it was really similar. It didn't show a whole lot of performance improvement in the tests that we looked at.
Mm-hmm.
So it's just kind of sat there for like 2 years. Maybe now though, as we're talking about direct IO and buffered IO and changing the way that we do writes, maybe it's worth actually looking at this more significantly.
I think it may show more benefit with C-Store in the future rather than BlueStore. More likely to be hitting those kinds of bottlenecks I'd expect with much faster devices.
One thing I was curious about, Josh, is whether or not, it looks like Jens spent a little bit more time thinking about buffered I/O in the I/O Uring context than they did with the Bay I/O. I was wondering if buffered I/O may actually be closer to the direct I/O level of performance without having to, do this kind of mixed direct writes, buffered reads kind of uh, uh, thing that Adam's proposing.
Do you think the overhead from the syscall interface itself might be significant? Being buffered
I
into
don't
the
know.
PAO?
I don't know. I don't actually know why we're seeing the performance regression with buffered writes that we do. I mean, it's not entirely unexpected, but I don't know if it's specifically because of syscalls. Do you have any opinion?
Um, I guess my intuition is that it's unlikely to be syscall related. It's more likely to be just like the RocksDB behavior that you were talking about.
Well, no. I was thinking more. Why do we see BlueFS writing so much faster with direct I/O than buffered I/O? That was the question that I have.
Oh, I see. I don't have any intuition there.
So my question is, given that it looks like Jens maybe actually thought a little bit more about buffered I/O in the I/O Uring context, maybe we could do buffered I/O and with I/O Uring and get closer to direct I/O levels of write performance while still having reads coming from page cache in a safe way.
I don't think it would affect the safety aspect. It's primarily changing the queuing mechanism to the kernel, right? You still have
Yeah,
underlying buffer mechanics within the kernel to contend with.
but what I mean is right now we see a regression in terms of 4K random write performance when we use buffered I/O, right?
Mm-hmm.
So in the I/O Uring context, can we use straight up buffered I/O and not have that performance degradation, so we don't have to worry about data consistency issues related to direct writes and buffered reads?
I see what you mean. Yeah, I would expect that the overhead's more related to going through multiple hops of memory in the kernel in the buffer cache,
Yeah,
not strictly
yeah,
to the way we're communicating with the kernel. So I wouldn't expect the IO to be a huge help there.
sure. That's a fair assessment. it's surprising to me that the buffer cache is kind of slow enough that we actually see it at like 60 to 70,000 write IOPS, which is kind of low, right?
Well, the buffer cache was designed, how many years ago, and with the write speeds.
Yeah. I guess the good news on that front is that we're fast enough that we're actually pushing those boundaries now.
Yeah, exactly. These are much higher numbers than we saw even a few years ago.
Yeah,
So
definitely.
speaking of the Linux storage stack, there's just a paper that ran across a few weeks back that was pretty interesting. Might be worth discussing in a future performance call, maybe, about re-architecting Linux internals to have much lower latency.
Neat. Yeah, this looks really interesting. I'm game. When do you want to talk about it, Josh?
I don't know, maybe say 2 weeks so that folks have time to take a look at it.
Yeah, that would be the 23rd. Looks good. I'm giving a talk on the 21st, I think, about Cephfs performance stuff. So I might be cramming and reading this on like the 22nd, but I think I can do that.
I've got lots of days before that too.
Oh, I know, but I don't. We'll see.
Yeah, I usually procrastinate reading these until the last day as well.
Yeah, there's a lot of stuff in the queue.
Yep.
Yeah, I can do 2 weeks. Other people, anyone have any opinions? Are we good with 2 weeks from now?
2 weeks sounds good.
Cool. Josh, did you already list this? I see you did. Good.
Yep.
And just add on here, discuss on, was that 9/23? Is that what we determined that was?
Yeah.
Yep. Cool. Yeah, I'll try to remember to send out a email reminder about this too, and a reminder next week at the performance meeting.
Cool.
All right. Well then, anything else, guys?
Just one comment. In 3 weeks, it's a holiday in Israel, so some people will be missing.
In 2
The
weeks or 3
shutdown
weeks?
is in 2 weeks. It's again 23, right? Yeah.
Yeah.
We have a shutdown here.
Oh, let's move it then. Let's change it then. What about the 30th?
We're okay. I'm okay.
Josh, does that work for you?
Probably. Yeah. Let's go with 30th.
Okay, cool. All right, 3 weeks from now, we'll discuss this. Any dissent? Cool. Sounds good. All right, anything else, guys? Then have a great week, everyone. See you next week.
Yeah.
Thanks. Bye.
Bye.
See you. Thanks.